In this video, we're going to discuss how domain names work. By the end of this video, you will gain a complete understanding of how domain names work, how domain names are resolved, what happens whenever you type in certain domain into the address bar of any browser. So in this case, I'm typing in app.eraser.io. We will learn how any web browser, so in this case I'm using Google Chrome, so we will learn how Google Chrome knows what data to get whenever I type in this domain name in the address bar. And we will also talk a few things about DNS servers. We will talk a few things about various kinds of DNS records such as A record, Quadruple A record, CNAME record, and a few other records that we're going to talk about at the end of this video. So in order to get this started, let's consider a basic scenario where we have a user. This user can be you, me, any user out there in the world that is interacting with the web browser and typing in whatever domain name that they would like to access. So this user interacts with a web browser. Let's say that this web browser is Google Chrome, and whenever user wants to get particular data about a website, the user will type in a domain name. So in this case, let's consider the user is trying to access fullstackpro.io. That's my domain name. So my first question to you is, can you think how Google Chrome knows what data to get for this particular domain name, fullstackpro.io? And if you are new to tech, you might not be able to answer it, but if you have been working on tech for a while, or if you even know if just a very few basic about website, then you know the answer that this domain name fullstackpro.io is associated with a particular IP address. So that IP address is, in this case, 127.0.0.0, and this is not the real IP address associated with this domain, but just for example, let's consider that this is the IP address associated with that domain. So whenever a user types in this domain name fullstackpro.io in Google Chrome initially does not know what the IP address is. So let me remove that from there, because Google Chrome will not know what the IP address associated with this domain name is. I was just showing earlier, typing in that IP address just to show you that every domain name out in the world is associated with a particular IP address. Okay, so in this case, the user is trying to access this domain name. Web browser do not know what this domain name contains, where to find the data for this domain name. So what Google Chrome will do is Google Chrome will make a request to something called a DNS server. This DNS server stands for domain name system. And whenever we say DNS server, that is the domain name system server. And these are the servers that translate a domain name. So in this case, this DNS server will translate this domain name fullstackpro.io into a particular IP address. It does not actually translate this domain name to the IP address, but for now let's just understand that's what the DNS server does. But in reality, this DNS server is basically just caching. You can think of this DNS server like a database that has a cache content that has the IP address of whatever domain name. So this DNS server is like a database that has the cache copy of the domain name and the IP address. So in this case, Google Chrome is requesting an IP address for this fullstackpro.io. So this DNS server will look to see, do I have a domain name for this fullstackpro.io? And let's suppose that this DNS server has this IP address, 127.0.0.0 for this particular domain name. So what the DNS server is going to do, and this DNS server, let me give you a few examples of this. So this DNS server Google is one of the DNS server that provides that service. There is a very popular one called Cloudflare. So these are just basic examples of some DNS servers. There are many other DNS servers, but these are the two most widely used. So whenever Google Chrome makes a request for this domain name, asks for the IP address, this DNS server is going to return this IP address, this 127.0.0 IP address, to the browser, to Google Chrome. And now what Google Chrome will do is Google Chrome will make a request to a server that has this IP address 127.0.0. So Google Chrome, after getting this IP address from the DNS server, Google Chrome can now directly make a request to this particular server, to this IP address. And this server can be anywhere out in the world. Okay, but now since Google Chrome already has the IP address, Google Chrome can directly make a request to this particular IP address, and then what this server will do is this server will return any data associated with this IP address. So now Google Chrome gets the data associated with this domain name, and you can see the data, any website data that you see in the browser. Google Chrome now has the data that this particular IP address, this particular server sent to the Google Chrome. So this is a very basic scenario. Everything is going all right. There is no any complications. So now let's look at what happens whenever Google Chrome makes a request to a DNS server. What happens if this DNS server does not have the IP address? How is DNS server going to be able to return the IP address to Google Chrome in order for Google Chrome to make the request to this particular server? So in order to understand that, let me delete some of this here. Let me remove that one too, because the DNS server in this case was not returning that IP address. Whenever Google Chrome sends this domain name to the DNS server, and you can think of DNS server as a database that caches the domain name and the IP address. So when we saw earlier, the DNS server was able to return that IP address of fullstackpro.io because it had the cache copy of that domain name and the IP address. But in this new scenario, what we have is the user is typing in fullstackpro.io in Google Chrome, and then Google Chrome is making a request to the DNS server. So in this case, this DNS server only knows the domain name. It does not have the IP address associated with this domain name. And can you think of the time when this can happen, when the DNS server does not have the IP address associated with any domain name? Can you think of a time when this can happen? Yes, that is whenever you register a new domain name or you transfer a domain name from one registrar to another. Whenever you do that in any registrar that you want, such as Route 53 or GoDaddy, Namecheap, any domain registrar, they will usually say that this might take 28, 48, 72 hours to complete. They will say that the domain name registration or the domain name transfer might take anywhere from 28, 48 to 72 hours. So during that time frame, the DNS server does not know the IP address associated with that domain name. So that's why whenever you register a new domain and you try to access that newly registered domain immediately, then you'll see in the browser that it will say the site cannot be reached. So that is happening because this DNS server does not have the associated IP address, does not have the IP address associated with this domain name. So in this case, since DNS server does not have the IP address of fullstackpro.io, what is going to happen? This DNS server will make a request to something called a root server. So this is the root server. And what are these root servers? I have a new tab open here. If you go to this website, iana.org/domains/root/servers, you can learn about root servers in this web page. So basically these are the main servers that give information, that give IP addresses of any domain, that actually translates or that actually tries to translate a domain name into a particular IP address, and root servers are able to do that. So currently we have, I think, about 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 root servers out in the world. And so these root servers will do the job whenever the DNS server cannot do the job. Whenever Cloudflare or Google cannot resolve a domain name into an IP address, then DNS server asks the root server in order to give the IP address associated with this domain name fullstackpro.io. So how does this root servers work? So within this root server, there are many different servers. So let me build some servers there. So there's another one, there is another one. Let me make this smaller a little bit. So these are all the servers of this root server. Okay, so let me make that smaller so that we can fit some more servers. So these are all the servers, all these boxes, these are all the servers of this root server. And what are all these servers? So this root server will have many different servers within it, and these servers are the TLD servers. Okay, and what are these TLD servers? In order to understand that, we need to first know what TLD stands for. TLD stands for top level domain. So what does top level domain mean? So if you look at this domain fullstackpro.io, the top level domain in this case is .io is the top level domain. And if you have a .com website or example.com, then .com is the top level domain. There are other top level domains like .org, even country specific domain like .us, .co, .uk, and all those are all top level domains. So these root servers will have all these TLD servers, and these TLD servers can be called, so in this case, if the domain name is fullstackpro.io, then this TLD server is called .io server. And we also have a server for .com server, .com TLD server, just to be specific. And we also have .org server. And we also have, let me write some country specific server like .np. That's for .nepal. So within this root server, we have many different this TLD servers, .io server, .com server, .org server, .np server. So what is going to happen now is whenever this DNS server makes a request to the root server with this particular domain, what the root server is going to do is this root server is going to forward that request to these TLD servers. And how does root server know which server to forward this request to? Whenever DNS server sends this domain name fullstackpro.io, the root server will look for the top level domain of this domain name. So in this case, the root server knows that the top level domain of this particular domain name is .io. So that's why this root server will forward the request of the DNS server to the .io TLD server. So now the request is with .io TLD server. So now what this TLD server is going to do is this TLD server will send its IP address, send the IP address of this .io TLD server to the DNS server. So now the DNS server again will make a direct request to this .io server, because this domain name ends in the TLD of this domain name is .io. This DNS server will make a request to the .io TLD server, and again what this .io TLD server will do is it will try to find out who the authoritative name server for this TLD server is, that is the .io TLD server. So it will try to find the authoritative name server, and that authoritative name server can be either AWS Route 53, GoDaddy, Namecheap, wherever that domain name is hosted or domain name is registered. This TLD server will return that particular authoritative name server. So in this case, let's consider that the authoritative name server is GoDaddy, and this TLD server, what this will do next is this TLD server will send the IP address of this authoritative name server to the DNS server. So now the DNS server has the IP address of GoDaddy, because now DNS server knows that this domain name fullstackpro.io, this domain name is registered with GoDaddy. So now the TLD server sent the IP address of GoDaddy to the DNS server. So now the DNS server knows that this domain name is registered with GoDaddy. So now what this DNS server will do again is this DNS server will make a direct request to GoDaddy. And what GoDaddy will do next is GoDaddy will check does this domain name fullstackpro.io, does this domain name exist in my database? And if it does, then GoDaddy will return the IP address to the DNS server. So now the DNS server has the IP address 127.0.0.0 of this particular domain name. So now the DNS server has the IP address associated with this domain name fullstackpro.io. Now will the DNS server make all this loop again? No. Because why? Because DNS server now already has the IP address associated with this domain name. So all these steps here can be ignored the next time the user types in fullstackpro.io. So can you think of a time when this DNS server will have to make this request all over again? There are a couple of scenarios when the DNS server will make this request, will make this loop all over again. Can you think about it? And yes, that is whenever you buy a new domain name, or let's say that you create a new subdomain. For example, in my case, if I create a new subdomain called blog.fullstackpro.io, that new subdomain is going to have a new IP address. Okay, so let's say that this user is typing or going to Google Chrome, and if this user is now trying to access blog.fullstackpro.io. So now Google Chrome sends this request, this blog.fullstackpro.io, to the DNS server. Does DNS server have IP address associated with blog.fullstackpro.io? No, it does not. It only has the IP address for fullstackpro.io, and of course this subdomain blog.fullstackpro.io, we can point this to fullstackpro.io, but just for example, let's say that blog.fullstackpro.io is a completely different department or completely different aspect of the website. Then this DNS server is now going to have an IP address of this blog.fullstackpro.io, and in other words, is not going to have the IP address of the server of wherever this blog.fullstackpro.io is hosted. So what the DNS server is going to do, the DNS server is of course going to have to make all these requests all over again in order to get the IP address for blog.fullstackpro.io. So that was one case when the DNS server had to make all these requests. And there is another one that I can think of too. There's the second case, second scenario I can think of where this DNS server has to make all these requests. So try to think about it when that can happen. And that can happen. So let me remove this for now. That is not needed. So that can happen when, let's say that in this case, the user is trying to access fullstackpro.io, the same domain name, and the DNS server already has the domain name 127.0.0, but we are trying to think of a scenario where this DNS server still having this IP address, DNS server will still have to make the request. And that is when I move my resource, I move my website that is hosted on 127.0.0.0. If I move my website from this particular server, this particular IP address, if I move my website to a new server, so right now I have my website hosted on Amazon EC2. If I move my website, all my data, to a new Amazon EC2 instance, or maybe Amazon S3, I am going to get a new IP address. So when I move my resources from one server to the other, it is going to get a new IP address. So that time, this DNS server will have to do this loop all over again. And what happens if the DNS server does not do the loop? When I move my resources from one server to another, will still return this 127.0.0.0 IP if it does not make this loop, and then it will return this IP to the browser, and then the browser now will make a request to the same server, and what is going to happen? The browser will display this page cannot be reached in the browser. And that is, you must have seen this a lot of time whenever you try to access some resource, and then the browser will say this page cannot be displayed, or resources not found, or something like that. So that's what will happen if the DNS server does not make this request. But if the DNS server makes this request, and now since I have a new server, I have my resources on new server, so let's say that new server's IP is 127.0.0, and the DNS server makes a request to the root server, it is going to get this new IP address and then send this new IP address to Google Chrome, and then Google Chrome can make a request to that particular IP address 127.0.0.1 and then get the data associated with that IP address. So let me put that 127.0.0.0 there. So now DNS server has the IP address. All this are not needed anymore. So let me remove that. So now we are back at where we started. There is a user opens a web browser, types in fullstackpro.io, and then the browser makes a request to the DNS server, and DNS server has the domain name, and now the DNS server already has the IP address, so the DNS server is going to return the IP address to the browser. And again, we are right where we started. This Google Chrome will make a request to a server, and in this case it was EC2 instance, because that's where my website is hosted. So now, since Google Chrome already has the IP address associated with this domain name, Google Chrome is directly going to make a request to that IP address. In this case, it's EC2 instance, and AWS or Amazon is going to send the data, send every single resources associated with that IP address to Google Chrome, and Google Chrome displays the data, and then you see a data on my website. So that was the entire architecture, entire workflow of how domain names are resolved and how DNS servers work. So let's look at a few more things here. I would like to show you a few more things. So I have my domain name fullstackpro.io registered with GoDaddy. If I come down to my DNS setting, you can see that I have all these records here. So each of this is a record. I have all these are DNS records. So I have a type A record, type NS record, I have CNAME record, I have SOA record, and I also have a TXT record. So let's learn a few things about all these kinds of DNS records. So let's learn about type A record first. We use type A record every single time we want to assign our domain name to an IPv4 address. So you can see here I have assigned my type A record to point to an IPv4 address. What this is going to do is whenever you come to my website fullstackpro.io, this naked domain, that domain is going to point to this particular IP address. In other words, this is, since my website is hosted on EC2, this IP address is the IP address of that EC2 instance. So if I type in this IP address right in the browser, am I going to be able to access my website? It says connection is not secure, but if I just proceed either ways, it is going to access my website. So that is going to work, and I still need to work on this. It's not done yet, but that's the type A record. And there is also another type of record that is not over here. Let me talk about that quickly. It was right here. So there is another type of record called a quadruple A record. That is AAAA record, 4 A's. We call that a quadruple A record. What that record is going to do is it is going to, whenever you want to assign your domain name to an IPv6 address, you use quadruple A record. So type A record is used to assign your domain name to IPv4 address. Quadruple A record, 4 A's are used to assign your domain name to IPv6 address. And what is the difference between IPv4? This particular address is the IPv4 address. What is the difference between IPv4 and IPv6 address? And of course, there is a lot of differences, but why do we even need IPv6 addresses when we already have IPv4 addresses? It's because these IPv4 addresses we are running out. There are about 4.3 billion IPv4 addresses that could ever be created, about 4.3 billion. So that's why we are running out. And you can think that, are there not more than 4.3 billion devices in the world? Probably yes. So we are almost running out of IPv4 addresses. So that's why, in order to fill that gap, we needed an IPv6 address. And how many IPv6 addresses are available? There are infinitely many IPv6 addresses available. The number is so large, you can Google it, number of IPv6 addresses. It's very, very large number. And we are most likely never going to run out of that IPv6 address. But that was about type A record and quadruple A record. Let's come to this NS records. This stands for name server record. And this NS record, right now I have it pointed to this ns19.domaincontrol.com. This is provided by GoDaddy. If I move my domain name from GoDaddy to Amazon Route 53, which I'm going to do in the future, this name server is going to change also, because my registrar had changed from, will be changed from GoDaddy to AWS Amazon Route 53. So I will be getting a new name server. And these name servers, we can create our own name servers as well, but this is not the scope of this video. But if you'd like to see that, feel free to leave a comment in the comment section below, and I will make a detailed video about this, about how to create our own name servers as well. And let's come to this CNAME record, which you might have heard of. This stands for canonical name. These CNAME records are used whenever you want to create an alias for your root domain. So in this case, I'm using a CNAME record in order to create an alias. So this www is an alias. We can also call this a subdomain or www version of the domain. I'm using the CNAME in order to create an alias www for my domain fullstackpro.io, for my root domain fullstackpro.io. So CNAME records can be used to create alias for the root domain. Okay, and so you might ask, instead of using CNAME, can we use a record here instead of using CNAME? Yes, we can, and I will show you the difference when we come to my another domain. But in this case, I am using CNAME, and this www version is pointing to fullstackpro.io, and this fullstackpro.io, what is the domain, what is the IP address for this? It is right here, IPv4 address. This fullstackpro.io is connected to my IPv4 address. So what CNAME is doing is, whenever users go to www version of fullstackpro.io, they are getting the resources from this particular IP address. So now what happens is, if we get rid of this CNAME and assign this as an A record and write www here, leave it as it is, and then copy this domain name and paste it over here. So that is going to be A record www and then IP address. So what's going to happen is, let's say that we can, so this is one subdomain. A website can have many subdomains, right? So I can have a different domain from my blog app. I can have a different domain from my admin app, like admin.fullstackpro.io, blog.fullstackpro.io, quiz.fullstackpro.io if I am running a quiz on my website. So those are all the subdomains. So what's happening, and all the subdomains, all those resources are hosted on this IP address, on this EC2 instance. So what is going to happen if I assign a record, and then, so this will now be blog.fullstackpro.io, and then type in this IP address here. If I have 100 subdomains, then I'm going to type in this IP address for each of the subdomains, because I am using an A record, which I'm not. But if I use the A record, that's what's going to happen. I'm going to have to copy this IP address and paste it in all over again. And then we saw earlier how domain names are resolved. That process, that loop that we were talking about, that is going to happen all over again. Okay, so that's for the CNAME record. And we also have SOA record. This is called the start of authority record. So this record basically contain information about the domain name and the owner information and such. There is also another kind of DNS record called a TXT record, and this kind of record, as TXT means text, right? So this kind of records can be used to verify your site with Google. So if you want to verify your websites with Google, then on the Search Console, Google will give you this Google site verification code, and then you come to your DNS setting and create a new record called TXT record, and then paste in that Google verification code, and then now your site is verified with Google. Okay, so those are all the DNS records I have in this particular domain. But if I also have another domain here, and this one is hosted on Route 53. So this fullstackpro.io is hosted on GoDaddy, but now pilotpro.io is hosted on Amazon Route 53. And there are a few differences here. So record name, I have, that's my pilotpro.io. I am assigning it a type A, giving it a type A record. And then instead of pointing it to a specific IP address, like we did before, we specified a specific IP address for fullstackpro.io. But for this particular domain, I'm actually pointing it to a CloudFront distribution. So if you do not know what CloudFront is, it's just a CDN that is used to serve your website to the nearest user. So whenever the user accesses pilotpro.io, CloudFront is going to give that user the data from the nearest location of that user. Okay, so we have a type A record, and the difference that I was talking about over here is in www version, the subdomain of this domain name pilotpro.io, here I'm assigning an A record, and I'm pointing this to a CloudFront distribution. I'm doing this manually. So what's happening? If you look at this CloudFront distribution, so this starts with D2B, and then this CloudFront distribution starts with DCD. So these are two different CloudFront distributions. So this one was for the root domain, and the other one was for my subdomain, that is www version. So I'm actually assigning, by using A record, I'm assigning it's the same website, www, it's just another version, it's subdomain, but that suits to usually www version points to the main domain, right? It's the same. It's just for the look of it that we are www. So over here, what I'm doing is I'm assigning an A record, and it is getting data from another CloudFront distribution. And of course, I will make a correction to this, but I was just doing this to show you an example of what happens when we do not use a CNAME record and use A record directly and assign the value directly. Now, if I have more than, let's say, 50 subdomains, and for all those subdomains, if all of my resources are hosted on this CloudFront distribution, then I'm going to have to, if I'm using A record, I'm going to have to manually write these values. So, and that is very tedious. So that was, we do not have any other records. That was it. And there are many other kinds of records that we're not going to go through this video. Most of the time, these are the most commonly used DNS records. So I hope you found this video useful. And again, if you would like to see anything new, if you have any new topic that you want me to go over, then feel free to leave a comment down in the comment section below. Thank you for watching, and I will see you in the next one. Ciao.